Hello there, welcome to our Fantastic channel. In this video, I will go over a geometry problem with you by step-by-step explanations. I will also be talking about memorizing formulas versus actually understanding them in order to be able to remember them easily. Learning is not just memorizing formulas, but truly understanding them. Memorizing a bunch of stuff to make the learning process go faster is like trying to fasten the fermentation of a yogurt. For your information, it takes a couple hours for your milk to turn into yogurt, and if you somehow try to shorten this amount of time, it simply won't work. Okay, let me cut to the chase. I believe that truly understanding the reasoning behind math is more effective in learning than just memorizing formulas to pass a test. Just like how you can't make yogurt if you pass in the fermentation. That's why I wanted to show you a couple postulates and theorems that are commonly used in geometry. After watching this video, you will hopefully always remember them. Now that I'm done with my short speech, we can move on to the postulates and theorems. I have a stick here, 3 triangles, well actually these are supposed to be angles, and 2 parallel lines, and by that I mean that if these 2 lines were to keep going for forever, they would never intersect since they have the same slope. These signs mean that they are parallel. I cut these angles in a way that this one would equal to 30 degrees, this one would be equal to 45 degrees, and this one would be 60 degrees. So, according to the alternate interior angles theorem, if we put this stick in a way that it goes through both parallel lines, let's say this angle right here is 60 degrees. This angle and this angle should be equal according to the theorem. I want to try it if this angle fits here, and boom, it fits. Now let's try the 45-degree one. We could put it the other way too. If we put the stick this way, then these 2 angles and these 2 angles would be congruent. Congruent means equal. Let's make this a 45-degree angle. Now let's put it right here, and it works. Last but not least, and by the way, this angle doesn't have to be 60 degrees, 45 degrees, or 30 degrees. It can be any type of angle. I just wanted to show a couple examples. Since the alternate interior angle of this angle is this one, we put the angle here and it fits. Now you know how the alternate interior angles theorem works. Now we can move on to the geometry problem. Now we have the theorem proved. Let's solve this question. So there's the ABC triangle, and it is a right triangle. The question is asking for us to find the measure of this angle, which we will be calling theta 1. The question states that this line is parallel to this line. Remember the alternate interior angles theorem. If you could recall, this angle should be equal to this angle. Stick goes here, and these 2 would be equal. Let's call this angle theta 2. We're given 2 sides of the triangle, the ABC triangle. The measure of the side AB is 5. The measure of the side BC is 4. So let's see what we can do. We're given two sides and we have to find the angle between them. We can use one of the trig functions, right? This is the angle and this side is adjacent to that angle. This side is the hypotenuse. We're going to be using the cosine of this angle because cosine of theta 2 uses the adjacent and the hypotenuse.
Sine, adjacent, hypotenuse, cosine, adjacent, hypotenuse, cosine, adjacent, hypotenuse,
which equals 4/5. But we need to leave theta 2 by itself on this side. So we're going to take the inverse cosine of both sides. That leaves us with theta 2 equals inverse cosine of 4/5, which is equal to, if we type that in the calculator, is approximately 36.9 degrees. Since we know that theta 2 equals theta 1, we can say that theta 1 approximately equals 36.9 degrees. And that's it. See, it's very simple to solve problems once you understand the theorems or the formulas. And you're welcome for this Geometry 101 lesson by me.